Good evening, students. In this session, let us see few important very short answer questions of your IPE examination class 12. Okay, as you know, you need to attempt all the questions of this VSAQs in your final exam. So concentrate very well on the topics first, and next concentrate on the application part, because these 2 marks questions may include the problems also. It means very short problems with the one formula based problems. So let us see each and every chapter model based few very short answer questions. So let us see first about solid state. From this solid state, you may guess questions like this question, like you can see on the screen, what makes a glass different from quartz? It means you need to mention, you need to think about the strategy of the differences between a glass and a quartz. Just implement those differences in your answer. See, write them in the form of a box, like 2 columns, one is for quartz and one is for glass. What is quartz? It is a crystalline solid, and glass, it is an amorphous solid. And quartz, it has long range order, and glass has short range order. So these are the 2 differences. Since this is a 2 marks answer question, 2 differences are enough. They are you can get full marks if you write those most important differences between these 2 elements, that is glass and the quartz. And you have one more example question, like distinguish between a crystal lattice and a unit cell. So just remember definitions of crystal lattice and unit cell. Both may carry 1 mark each. So what is crystal lattice? It is a regular repeated 3D arrangement of the particles in the space. So this is called crystal lattice. And what is a unit cell? A small portion of the crystal lattice. It is called unit cell. You can remember in this way. If this is any element, so in this, the small part, the smallest part, that is known as unit cell. If you multiple these unit cells, there will be a formation of a crystal, that is the element, that is crystal. Remember in this way, by uniting all these unit cells, you will get crystal. And next, the one most important concept of this solid state, you can guess 99% of this questions, defects questions. That is, one of the defect is Schottky defect. So what is Schottky defect? This is the defect which arises when equal number of anions and cations are missing from the lattice. So remember, when there are equal number of anions and cations lost, in those type of defects, we can see this Schottky defect. With this Schottky defect, we have few loss, that is the density is decreased because of the loss of ions. Density will be decreased. It is most common in ionic compounds with a high coordination number. See, since this is shown in ionic compounds, examples will be NaCl, KCl and AgBr. So this diagram is also important. This also carries half of the mark. So this is about Schottky defect. And next about Frenkel defect. This Frenkel defect, this is entirely different from the Schottky defect. In that Schottky defect, equal number of cations and anions will be lost. This Frenkel defect is when the ion displaces from its normal position. It means you can see in this diagram, actually the place of A plus will be here, but it displaces to here, that is it is forming it is searching its new place, that is here A plus. It means there is no decrease in the density but change in the place of this ions, that is this Frenkel defect. What happens with this Frenkel defect? The density remains constant, and this type of defect is commonly seen in ionic compounds with low coordination number. For example, you can see this type of defects in zinc sulfide ZnS and AgBr silver bromide. So these are two important defects of the solid state. And next we have type of stoichiometric defect. Which type of stoichiometric defects are shown in ZnS and AgBr? In zinc sulfide, as if you remember the examples of this is a Frenkel defect, this zinc sulfide shows Frenkel defect, and this AgBr silver bromide shows both Schottky and Frenkel defect. This you can expect this type of questions also. And one more type of question, what are F centers? F centers. So this is a simple answered question. Just define what are F centers first. These are the anionic sites that are occupied by unpaired electrons. These are known as the F centers. These are responsible for the color and paramagnetic nature of the crystal. So this point is also carries half of the mark, and you can, as the number of F centers increase, the intensity of the color also increases. So these 3 points are important for this such type of question, F centers question. And next, one more important defect, interstitial defect. So what is this interstitial defect? This arises when other atoms or molecules occupy the interstitial site of the lattice. See, here other atoms or molecules, not among the crystal but other atoms or crystals. You can see this is a complete iron crystal. You can see a occupancy of a new compound in between this iron, that is the carbon, that is the carbon is occupied in this in between iron. This type of defect is known as interstitial defect. This is, you can see this in stainless steel. If addition of carbon to the iron, then that becomes stainless steel. In that type of compounds, you can see this interstitial defects. These are the few concepts, you can expect this type of few concepts in this solid state. And next, from solutions, this is also one of the important topic which you can expect 2 marks questions. Here most important law, that is Henry's law. So let us see what is Henry's law. Here Henry's law is the partial pressure of the gas in vapor phase, which is directly proportional to the mole fraction of the gas in the solution. Mainly Henry's law defines about the partial pressure. So here, as per the definition, P is directly proportional to its mole fraction. To remove this mole fraction, we are adding a constant, that is Henry's constant Kh. So this, in this way you need to answer this direct answered question. This is nothing, no sort of application you can see in this type of questions. So this is a direct question. Just write the law about Henry's law, and next explain how it is applicable in type of formula. Enough, you can get easily 2 marks. And next important point in the solutions, that is relative lowering of vapor pressure. So what is relative lowering of vapor pressure? Just you can define this formula. The ratio between lowering vapor pressure of the solution and vapor pressure of the pure solvent. That ratio is known as relative lowering of vapor pressure. You can define by writing this formula. From this relative lowering of vapor pressure, we can also define this Raoult's law. This is also an important question. You can see this is the most repetitive question also. So what is Raoult's law? Here this Raoult's law, this mainly depends upon the relative lowering of vapor pressure. According to this Raoult's law, the relative lowering of vapor pressure of the dilute solution of a non-volatile solute. This is more important. In Raoult's law, we use non-volatile solute, that is equal to the mole fraction of the solute. You can see here that relative lowering of vapor pressure is equal to the mole fraction of the solute. We have seen as per the above question the relative lowering of vapor pressure formula, which is equal to the mole fraction of the solute. If you write in this way, this definition may carry 1 mark, and this formula which you write below the definition, that carries 1 mark. You can easily get 2 marks, and this is the most important question, this Raoult's law. And you can also expect some application based type questions also. Very simple application type questions you can expect from in this very short answers. And you can see questions based on colligative properties. That is, what is osmotic pressure? See, this is one of the colligative property in our solutions chapter. So this is defined as the pressure applied on the solution to stop the osmosis process. This is called osmotic pressure. It is denoted by pi. This pi is equal to CRT. Here C is the concentration of the solution, R is the universal gas constant, T is the absolute temperature. So this is about osmotic pressure. And since there are more number of formulas in this solution, you can also expect some application based questions like how to calculate molarity, how to calculate molality, and normality and mole fraction. Here we have some example problem to calculate molarity of a solution containing 5 grams of NaOH in 450 ml of solution. See, they are asking directly to calculate molarity. So remember the formula of molarity. So what is molarity now? Molarity is equal to, since weight is given, I will write in terms of weight, weight by gram molecular weight into, we are in molarity, we will use volume. So that volume is taken in milliliters. So this, if you convert it into milliliters, 1000 by V in ml. So this is the formula you need to apply in this question. Here you need to calculate gram molecular weight of this sodium hydroxide. You can see in this question, just remember few gram molecular weights. Just remember gram molecular weights of 1 to 20 elements roughly. Not their exact values. Just remember their roughly values. It means most of the compounds will have double of their atomic numbers. Most of the, that is 1 to 10 elements will have double of their atomic numbers. You can remember in this way. So whenever you solve an application based question, you need to mention the formula clearly first. This formula also carry few marks, that is depends on the question. Since it is a 2 marks question, this formula may carry 1 mark, and the process how you solve the question, this may carry 1 mark. The final answer, how you get the final answer, that completely carries 1 mark. So this is how the marks will be awarded. In this way you can see in the answer how we can calculate molarity by taking the given things. First we have weight first, next we are calculating gram molecular weight, and next volume of the solution, that is given in ml. So 450 ml. Take the formula in milliliters since it is given in milliliters in the question. Now apply it, you will get molarity. In this way you need to solve the question, and remember few more formulas which are helpful to you. This is about molarity. Now remember formula of normality. What is normality? Weight by gram molecular weight. Here, sorry, it is not gram molecular weight. In normality we will use gram equivalent weight. In normality we use gram equivalent weight, and we will have same formula of 1000 by volume in milliliter. This is the formula of normality. Here the difference is gram equivalent weight. And next we have molality. In molality what we use is weight by gram molecular weight into 1000 by weight of solvent in grams. Since we are dividing it by 1000, we are taking it in grams. So this is the formula. And next we have one more term, mole fraction. Suppose if we need to calculate mole fraction of a solute, what we will do is we will calculate number of moles of solute by number of moles of solution. This is if A is for solute and B is for solution. In terms of B, here in place of A, B will come, and it is divided by completely by Na plus Nb. And we have weight by weight percent formulas, volume by volume, and weight by volume percentage formulas. Remember those formulas also, which are very useful for your problematic questions. And next chapter is electrochemistry. From this electrochemistry we can expect lot of questions. From that I have took few questions to explain you. This is about the Faraday's laws of electrolysis. So explain first what is a Faraday's law. First law. So what is the first law of Faraday? Here the mass of the substance which is deposited at the electrode, that is directly proportional to the quantity of the charge passing through the electrolyte. In the electrolysis setup, the mass of the substance which is deposited at the electrode, one of the electrode, that is directly proportional to how much current we are passing into it. That is given by this formula, M is directly proportional to Q. This is about first law. So whatever you write it clearly. And next similarly write the formula of second law also. So what is the formula of second law? We are comparing here with two different electrolytes. So see the formula, see the definition. When the same amount of current passing through different electrolytes, means different electrolytic solutions connected in series with combination. In series we are connecting those two electrolytes. Here the masses of the substances deposited at the electrodes that are directly proportional to their equivalent weights. In first law it is directly proportional to the charge. In second law, it is proportional to their equivalent weights of the electrolyte solutions which we are taking. Here, since we are taking two different electrolytic solutions, let M1 be the mass of the first electrolyte and E1 which is deposited, and E1 is the equivalent weight of first electrolyte. Similarly, M2 and E2, those ratio are equal to each other, that is M1 by M2 is equal to E1 by E2. This is the Faraday's second law. And next, one more important law, that is Cold-Rush law. This is the most easiest law in this electrochemistry. You can save time also. Here in case of questions will come, practice more questions of this Cold-Rush law. So what is Cold-Rush law? Here this Cold-Rush law states that the limiting molar conductivities of an electrolyte is equal to the sum of the molar conductivities of anions and cations. You can observe the example here. If we are taking the electrolytic solution of this NaCl or salt solution, what happens? Here the limiting molar conductivity is equal to its molar conductivities of its ions. Here in NaCl we have Na plus and Cl minus ions, that is lambda naught of NaCl, that is equal to lambda naught of Na plus plus lambda naught of Cl minus. This is about Cold-Rush law. And next, if we have different types of cells in this electrochemistry chapter, study all those cells, and you can also expect the long answer questions from this cells topic also. If it is given in the short answer, it may ask in this way: what is a galvanic cell or a voltaic cell? A direct question. Just define what is galvanic or a voltaic cell. We have two types of cells mainly, that is galvanic cell. One of it is galvanic cell. So here, this galvanic cell or voltaic cell, that is the cell which converts chemical energy into electrical energy by spontaneous redox reaction. See, here in galvanic cell we have conversion of chemical energy into electrical energy, that is this galvanic or voltaic cell. Example is Daniell cell. And one more cell is electrolytic cell. It will have opposite mechanism, that means chemical energy is converted into electrical energy in galvanic. In electrolytic cell, electrical energy is converted into chemical energy. As in those type of cells, we can apply this Faraday's laws. So this is all about galvanic cells. And next, let's see few topics of this chemical kinetics. And one more point, we have in this electrochemistry the concept of batteries also. There will be some direct questions from this batteries concept also. What are primary batteries, what are secondary batteries? Primary batteries are nothing but they cannot be rechargeable. Secondary batteries, they can be rechargeable. You can see once those examples. And coming to this chemical kinetics, the most important chapter. Here the main basic concept is to learn about order of the reaction and molecularity of the reaction. Here in this question we can see what is given. Define order of the reaction. Illustrate your answer with an example. So whenever there is a question in this way with an example, you must and should write the related example to that question also. Here what is order of the reaction? Here the order of the reaction is the sum of the powers of concentration terms in the rate equation. Suppose if we have a rate equation in this way, that is K of concentration of A to the power of X to the concentration of B to the power of Y. Suppose this is the rate equation. for x moles of A plus y moles of B, that is giving rise to products. This is the main equation and this is the rate equation. In order to define order, what we do is we will add the coefficients of this A and B, that is x and y. This x plus y gives the order of the reaction. In our syllabus we have mainly 0 order, first order and second order, and most of the questions will be asked from this first order reactions, and few small questions like this in this very short answer questions, they may come from this 0 order. And remember, for every order of reaction there will be half-life time. Remember that formula also for every order of the reaction. Here what is given? Give 2 examples for 0 order reactions. It means the sum of their coefficients will be 0 in such type of reactions. Here we have a reaction how glucose is prepared from carbon dioxide and water. This is the photosynthesis reaction. This is 0 order, and this ammonia formation, reversible reaction of this ammonia. In this 2 moles of NH3 is giving rise to N2 plus 3H2, and we have one more reaction, iodide, hydrogen iodide, which is giving rise to hydrogen and iodine on heating. These are few examples of 0 order reactions. And next we have concept of complex reactions. What are complex reactions? See, name itself we have complex. It means it may be having group of reactions. Just remember in that way what those group of reactions come from the elementary reactions. But that is a sequence of elementary reaction. That type of reactions are called complex reactions. Here you can see C2H6, this on reaction with chlorine, it is forming a substitution reaction of chlorine. On reacting with a base, this chlorine is substituted by this OH. This undergoes a aldehyde formation, which on oxidation it further gives a carboxylic acid, which this carboxylic acid is converted into carbon dioxide and water. Here we have a group of elementary reactions which on combination forms a complex reaction. Next, you can also expect the important concept question, that is about Arrhenius equation. Here a question is asked in this way: what is the effect of temperature on rate constant? If a question is asked in this way, remember what is the relation between temperature and rate constant. How can you derive this relation? It can be derived from this Arrhenius equation. So simply write about Arrhenius equation. Or a question is directly asked in this way: write the Arrhenius equation for the rate constant K of a reaction. So you need to answer in this way. Just define what is Arrhenius equation. So what is Arrhenius equation? The rate of the reaction increases with increase of temperature. That we need to show in the formula, in type of formula. That is, we need to relate in between temperature and the rate constant. It is shown in this way. Here K is the rate constant, that is equal to A e power minus EA by RT. This is about the relation between the temperature, this temperature and rate constant. Here this K is the rate constant and A is the Arrhenius factor, EA. Here minus EA. In this EA is the activation energy. This activation energy is the energy required for colliding the particles in the reactant molecule to form a good amount of product. that is this activation energy, and where R is the ideal gas constant and T is the absolute temperature. So this is about Arrhenius equation. When a question is asked on this Arrhenius equation, remember the temperature is given in absolute form or not. It means in units of Kelvin. If not Kelvin, if it is given in degree centigrade, you need to add 273 value to convert it into Kelvin. So remember in this way. As we have said earlier, there may be questions on half-life period also, because that is also important concept in this chemical kinetics. We have a question in this way, that is half-life of first order reaction is 60 minutes. Find its rate constant. In this directly it is given about first order reaction. So remember the half-life formula of first order reaction, that is T half is equal to 0.693 by rate constant K. What is asked? To find its rate constant. Half-life is given as 60 minutes. Substitute it in place of T half and you have value of 0.693. Just divide both of them, you will get the value of this rate constant. And the most important point in any problem is to mention units of the answer. Right, if you mention the units, then it will be the appropriate answer. So here this rate constant will get in the form of minute inverse, because if you take this rate constant to the left side and T half to the right side, what happens? It will be inversed. The time unit, that is the minute, will be inversed. So that is written in the final answer as minute inverse. In this way you can get few problematic questions from this chemical kinetics. And next we have concept of metallurgy. So metallurgy, mostly the questions comes in the form of it's asking in its find the ores of the metals, like how aluminium ore, what is the formula of the aluminium ore. So we can get this aluminium from the ores of this bauxite and cryolite. Just remember these formulas of these ores, they are very useful. Remember this, because there is no application part, just it depends on your memory. You need to practice lot of time so that you can remember these formulas. Just remember the formulas of these few metals. For aluminium, that is bauxite, formula is Al2O3, 2 moles of H2O. Cryolite, Na3Al(F6). Practice more number of times so that you can remember these formulas. Next, for iron, hematite, formula is Fe2O3. Magnetite, its formula is Fe3O4. For copper, it is in the form of copper glans. We have its formula as Cu2S. Cuprite, its formula is Cu2O. And next, zinc blende, its formula is ZnS. And zincite, it is ZnO. So remember in that way. And you have one more important question. What is blister copper? Why is it so called? This may carry 1 mark and this may carry 1 mark. So what is this blister copper? See, during the cooling of matte, the solved SO2 comes up to the surface and forms blister. Here we have few refining process in extraction of metals. Study those process also, refining process of metals. In that you have few terms like flux, gangway, and in the type of few terminologies are there. Just remember the definitions of those terms also. We have like slag, so remember these definitions also. These will come in this refining processes. Similarly, in those refining process of this copper, we have a cooling mat, that is dissolved SO2, that comes to the surface in the forms of blisters. In that way, the resulting copper that is formed, that is known as the blister copper. In this, we can get a variety of copper, that is 97 to 98% pure copper. So in this way, you need to answer this questions in metallurgy. We have lot of refining processes, and we have few compositions also in this, like composition of brass. This consists of copper plus zinc, which is copper is 60% and this zinc consists of 40%. So remember them also, because they also may be asked in very short answer questions. And one more composition, that is bronze. Bronze, which consists of copper and the tin. This is of 75% and this is of 25%. Next composition is German silver. In this German silver, we have combination of copper, zinc and nickel. So they are having 25% of copper and 25% of zinc and 50% of nickel. All this composition gives German silver. So remember them. They are also very helpful for your exam. This is about metallurgy. And next we have block elements. That is, in our plus 2 we have P block and D and F block elements. And this P block, we have about a group 15, 16, 17 and 18 elements. Here example question, that is, what is allotropy and what are the different allotropic forms of phosphorus. First you need to define what is meant by allotropy and what are different allotropic forms of phosphorus. See, what is allotropy? The existence of the same element in different physical forms. In different physical forms in the nature. That type of elements, that type of property, that is known as allotropy. Regarding phosphorus, this phosphorus can exhibit allotropic forms of white phosphorus, red phosphorus and black phosphorus. So this is allotropy and its allotropic forms of phosphorus. And next we have in this we can also expect some concept based questions. That is, you need to think about the concept, about the bonds, about the trends, periodic trends followed by these elements. That is also very important while studying this P block, D block and F block elements. For example, if a question is asked in this way, pH3 has lower boiling point than NH3. Here phosphine, pH3 is having lower boiling point than this ammonia. Why? In order to answer the type of questions, you need to remember the concept. Suppose if we take all the 15th group elements in its hydrides form, they are NH3, PH3, ASH3 and they will be SbH3. So what is given? We need to compare their boiling points. If we compare their boiling points, it will be in the order of this. It means ammonia is having high boiling point when compared to this SbH3. compared to this ASH3 compared to this PH3. Why? The reason, here the question is asked why. Here PH3 is having low boiling point due to the absence of intermolecular hydrogen bonds. So this is the very important reason. There are no intermolecular hydrogen bonds in PH3, while in NH3 we have presence of intermolecular hydrogen bonds. So in order to remember this concept, you must know what is hydrogen bonding. So what is hydrogen bonding? The bond formed between hydrogen and more electronegative element. Such type of bonds are called hydrogen bonds. Since the electronegativity of nitrogen is more compared to phosphorus, so in nitrogen there is a easy formation of intermolecular hydrogen bonding compared to this phosphorus. So this is the reason NH3 is having higher boiling point compared to PH3. And when coming to this D block and F block elements, you may expect some important concept based questions, that is to calculate magnetic moments. You need to remember the formula to calculate this spin only magnetic moment, which is measured in Bm, that is Bohr magnetons. So first of all, remember the electronic configurations of 1 to 30 elements first. In order to study this block elements, remember the electronic configuration of 1 to 30 elements, and remember the exceptional cases in this. Exceptional cases, like there will be some different configuration for chromium and copper, since they need to get electrons fulfilled. This will be having 3s1, 3d5, and this copper is also having 3s1, 3d10 type of configuration. Such type of exceptions, remember, so those type of exemptions, so that you can answer more concept based questions. Here it is asked about spin only magnetic moment of Fe+2 ion. In order to solve this type of question, you need to remember the configuration of Fe first with the atomic number 26. With this 26, it is having +2 ion configuration. It means in order we need to remove 2 outermost electrons. To remove 2 outermost electrons, we will get a configuration in this way, that is in the form of 3d6 and 4s1. So if you observe this configuration and write it in the form of in its orbitals, so it is filled in d orbital, right? D orbit has 5 orbitals. You need to arrange this 6 electrons in this 5 orbitals. That is, we need to fill in this way, as we all know how to fill these electrons. If we fill in this 6 electrons, there will be 4 unpaired electrons. That is, we can observe here we have 4 unpaired electrons. These 4 unpaired electrons are the value of n. The formula to calculate this spin only magnetic moment is mu is equal to under root of n plus 2 Bohr magneton. Here n is the number of unpaired electrons. To calculate those unpaired electrons, you need to remember the configuration. When you substitute the number of unpaired electrons in this formula, you will get the magnetic moment. Here you get mu value as 4.9. In this way you need to answer questions. And next we have one of the most important concept of this D and F block elements, that is about the lanthanide contraction. When it is given in very short answer questions, no need of expand much of this lanthanide contraction, just define what is lanthanide contraction and where you can see this lanthanide contractions. So in lanthanides, as the atomic number increases, what happens? Atomic number increases, atomic size gradually decreases. So this property, this decrease in the size, that is mainly because of the lanthanide contraction. When it is given in short answer question, this definition is enough. And next you may expect questions regarding the IUPAC names. Here you have few complexes. You can see here we have K4FeCN taken 6. There are certain rules to write the configurations of this complexes. If a question is asked in this way, first observe what is the central element. Here Fe is the central element. So after identifying this central element, what you need to do is you must calculate the oxidation state of this central element. See, you can see here we have K4FeCN6. Here the central element is Fe. We are taking its oxidation state as X, and there are no more charges present on this complete complex. So in order to calculate this oxidation state, we are equating it with 0. Since K is what type of element? Group 1 element, which is having common oxidation state of +1. Here 4 moles of K is taken as 4 moles, 4 into +1, and this iron, which is having 1 mole, it is multiplied by 1 of X, and the Cn, which is a negative ligand, that is -1 monodentate negative ligand, that is a -1 charge. After calculating, we will get the oxidation state of Fe as +2. So that is to be mentioned in its IUPAC name. If you write the name of this complex, so what is present in the beginning? K is present in the beginning, right? So what is K here? Potassium. How many ligands of this Cn is present? 6. This 6 is represented as hexa. And what type of ligand it is? Cyanide ligand, right? It is represented by cyano. And this Fe with oxidation +2, that is written as ferrate, and with oxidation state in its bracket as Roman number 2. Completely it is potassium hexacyanoferrate 2. In this way you need to calculate those type of questions. And if you see questions from polymers, there are you can expect few basic questions about the definition of the monomer and one of its example. What is monomer? It is a simple molecule capable of undergoing polymerization. This monomer multiplies to become a polymer. Here ethylene and vinyl chloride, these are examples of monomer. And if a question is asked to define polymer, just define it as a multiple units of monomer. You can see a macromolecule consisting of monomers. Example, polyethylene and polyvinyl chloride. These are few examples. And in this polymers concept, you must and should remember few basic monomer unit structures. For example, if there is a question asked to write with the structure and the monomer name, if it is polyethylene, what is the monomer? Ethylene. Write the monomer structure. Similarly, polyvinyl chloride, The monomer is vinyl chloride and the structure is in this way. And Teflon, it is polytetrafluoroethylene. The monomer is tetrafluoroethylene. Tetra means four fluorines are attached to ethylene molecule. Next, Buna N. We have Buna N and Buna S structures. 1, 3 butadiene, that is Buna N. Acrylonitrile, which on multiplies gives Buna S. The combination of these two, remember these monomer units and their structures. And here also we have few monomers and their structures. Here polymer is the bakelite and its monomer is phenol and formaldehyde. Write those structures. And this dacron, it is a mixture of this ethylene glycol and terephthalic acid. And glyptol, it is mixture of ethylene glycol and phthalic acid. Just afford some time for practicing these monomer units. If you repeatedly practice it, you can easily remember this. And we have a biomolecule chapter. There are very general questions and very easily answered questions from these biomolecules. The basic questions like what are vitamins, how they are classified. We all know vitamins which we require in our diet in small amounts for growing healthy and good maintenance of our body. There are two types, fat soluble and water soluble. What are fat soluble? Which are dissolved in fat, that is A, D, E and K. And water soluble, which are dissolved in water. Those are B group vitamins and vitamin C. And we have a concept of Zwitter ion. This is the most important concept, Zwitter ion. And we have what is a Zwitter ion? Here the carboxylic group loses one proton, it forms NH2, and you can see in this picture in the definition, in aqueous solution of amino acid, when the carboxylic group loses a proton and the carboxylic group, that is the COOH group, loses one proton and this proton is taken by this NH2 group, then there will be formation of two charges in a molecule, in a compound. That is, we have COO minus charge and NH3 plus charge. These two type of charges are present in a single compound. That type of compound, that type of ionic formation is known as Zwitter ion. You can observe this in amino acids. So remember the amino acids also. Because it forms two types of charges in a single molecule, that is the Zwitter ion, it exhibits both acidic nature and basic nature. That's why it is showing amphoteric in nature. So this is about Zwitter ion. And next we have chemistry in everyday life. And this concept mainly deals with the drugs, the part of the artificial sweetening agents, like this general concepts which we you can see we can answer in this chemistry in everyday life. We have few questions like what are tranquilizers, which is treatment used for treatment for mental disorders. The few examples of these drugs are Seconal and Veronal. Practice well. Just remember the definition of the few terms and examples, 1 to 2 examples for each term. Next, what are antacids? These are used to remove excess of acid produced in our stomach. These are known as antacids. Few examples: magnesium hydroxide, aluminium hydroxide, and ENO, which is available, which is a mixture of both this magnesium and aluminium hydroxide. And here we have antibiotics. What are antibiotics? These are chemical substances which are produced by microorganisms which are used to kill or prevent the growth of other harmful microorganisms. These are known as antibiotics. Example, penicillin types, amoxicillin and penicillin. And next, artificial sweetening agents. So what are the chemicals used in artificial sweetening agents? This aspartame, saccharin, sucralose, allitame. These types of chemicals we can use in place of sugar. So these are few questions of this chapter, chemistry in everyday life. And next, the most important concept of our chemistry, that is the organic chemistry. We cannot guess how questions will be asked from this organic chemistry, but remember the concepts, the definitions of few terms in this organic chemistry. If you remember the concept, how a reaction is taking place, or how a nucleophile or electrophile is attacked or removed on a substance, on a agent, on a reactant or a product. In that way, if you remember the concept clearly, you can answer the questions from this organic chemistry. Suppose if a question is asked in this way, what type of isomerism is exhibited by ortho, meta and para dichlorobenzene? These are the structures of this ortho, meta and para dichlorobenzene. So what type of isomerism we can see in these structures? It is position isomerism, because the position of chlorine is changing from ortho position to meta position to para position. So they are known as positional isomers, and we may expect question like this: what are ambident nucleophiles? What are ambident nucleophiles? In which the nucleophile in which there is a presence of two nucleophilic centers, two types of nucleophilic centers, those are called this ambident nucleophiles. In cyanide ion, we have electrons in this carbon and this nitrogen also, both can act as nucleophiles. So these are examples of ambident nucleophiles. This nitrate ion is also exhibiting this ambident nucleophilic nature. Because of the resonance, the negative charge in this oxygen can be rotated towards the other oxygen. You can see this questions of SN1 and SN2 reactions also. For suppose if a question is in this way, which compound in each of the following pairs will react faster in SN2 reactions with OH minus. So for this you need to remember the reactivity order of the SN1 and SN2 reactions. For SN1 reactions, tertiary alkyl halides will react fast compared to secondary compared to primary. For SN2 it is completely opposite. It means primary will be more reactive compared to secondary compared to tertiary. So from the given options, given question, search where is primary, where is secondary and where is tertiary. So from that you can answer the reactivity nature of the SN2 reactions. And next we have few very important named reactions in this organic chemistry. The main important reaction is Wood's reaction. If it is given in 2 marks, just define what is Wood's reaction, what is the product formed in this Wood's reaction. Here alkyl halides reacts with 2 moles of Na in presence of dry ether, it gives alkane. So this is Wood's reaction. And one of the important reagent in this organic chemistry is Grignard reagent. How Grignard reagent is prepared? It is prepared when alkyl halide reacts with magnesium. It forms RMgX. So this is about Grignard reagent. And next, one of the important topic, maybe this is the 99% chance important topic to be asked in 2 marks question, because this is the main concept here. What are enantiomers? That is, what are enantiomers? Define what is enantiomer. They are non-superimposable mirror images. Define it with an example of D-lactic acid and L-lactic acid. You will be awarded 1 mark for each. And next, what is racemic mixture? You can see this racemic mixture in SN1 reactions. What is the racemization? The process of formation of this racemic mixture. That is racemization. And resolution. That is the separation of D and L isomers from racemic mixture. Opposite to the racemization, that is resolution. See, these are the few definitions you need to remember. And next, there are few concept based questions. That is to compare the strength of the acids. Here acids are given as acetic acid, chloroacetic acid, benzoic acid and phenol. If you compare the acidic strength of chloroacetic acid is more compared to benzoic acid, next to acetic acid, next to phenol. This is because of the strength of the acid, because of the resonance structures present in that molecule, the strength will be increased. And next, a question from amines chapter, that is how aniline is prepared. By reacting this nitrobenzene in presence of this reducing agent hydrogen in presence of ethanol. These oxygens will be reduced to hydrogen and forms aniline. And next, we have in this amines chapter about Gabriel phthalimide synthesis, or it is the reaction for preparation of primary amines. What happens in this? The phthalimide, which on reacting with KOH, it forms in this way. When it reacts with a NK plus ion, when this reacts with any alkyl halide, it forms a composition of N and R. When this further reacts with a base, there will be a bond breaking here, which results in the formation of the primary amine. This is, remember, Gabriel phthalimide synthesis is used to prepare primary amines. This cannot be used to prepare aromatic primary amines. This only used to prepare alkyl primary amines. And there is one more important test, that is carbalamine test. This is also known as isocyanate test. What happens in this test? This test is used to detect the primary amines. When this primary amine reacts with chloroform in presence of KOH, it forms isocyanate and KCl and H2O. This is isocyanate test. This is also important test in amines. You can expect this questions also in very short answer questions. So these are few very short answer questions of your +2 chemistry. I hope you have understood how a question will be asked and how you need to answer for a 2 marks question. Just don't exceed it and don't waste your lot of time in this answering this 2 marks question. Answer it clear and short, and thank you for listening. All the very best.